You're tuned in to the Data Masters podcast. In each episode, we dissect the complexities of data management and discuss the data strategies that fuel innovation, growth, and efficiency. We speak with industry leaders who share how their modern approaches to data management help their organizations succeed. Let's dive straight into today's episode with Anthony Dayton.
Hello and welcome back to Data Masters. In today's rapidly evolving landscape, it feels like every conversation about data eventually becomes a conversation about AI. But beyond the buzzwords and the hype, what does this revolution actually mean for people on the ground, the builders, the analysts, and the leaders shaping our data-driven world? How do you separate the science fiction from the practical reality? To help us navigate these questions, we have a truly special guest today. I'm speaking with Ozair Ali, the co-founder of ekai, a new venture building an AI-based analytics and data operations tool right here in Kendall Square. But what makes Ozair's perspective so unique is his incredible background. With degrees from Wharton, the Harvard Kennedy School of Government, and Stanford Graduate School of Business, his career spanned from advising the government of Albania on restructuring its energy sector to co-founding Alter Global, a firm dedicated to scaling tech ventures in emerging markets. He's seen how technology can create systemic change on a global scale, and now he's at the forefront of the AI wave. Today, we're going to tap into that deep well of experience. We'll get his take on what it takes to turn cool science into a viable product, explore his views on the practical limits of today's LLMs, and discuss how AI will reshape the future of data careers. I hope we can also zoom out to look at the bigger picture, who will win the race for enterprise AI and where this technology will have the biggest impact in established Western markets or perhaps leapfrogging development around the globe. Ozair, thanks a ton for joining us on Data Masters.
It's a pleasure to be here, Anthony.
So let's start with a topic that you actually posted on some time ago on LinkedIn, and I sort of grabbed the quote. You posted, if you understand college statistics, you can understand the foundation of large language models. And I know you have a background in statistics. Do you think the industry kind of overcomplicates the discussion around AI, and makes it more than it is? What's your view?
I don't believe that there's any obfuscation going on deliberately. I think it's informative for me to think about my first ever big data course that I took at Stanford. And it was taught by a faculty member who has done pretty well for himself since, but his PhD was in electrical engineering. And that gives you a sense of where this field has developed. It didn't develop in the statistics and mathematics departments at universities. It developed either in the corporate world or within universities. It was within CS and electrical engineering. And so what that led to was that the vocabulary that's around AI or ML, which are essentially some version of a statistical model, is different from the vocabulary you would be familiar with if you took a basic statistics course. So if you have learned regressions, what you think of when I say inference, it may be different from what inference means today for CS or a CS major learning about LLMs. And so it's in my view, perhaps it was just the fact that in certain departments in universities, you just had, for lack of a better word, more snootiness. So if you didn't have, if you didn't have a causal chain of reasoning or a good way to explain why whatever you saw was happening, then it wasn't considered good research. Whereas perhaps in more engineering focused disciplines, it was like, this thing works, we're just going to have it work. We don't really care about getting into the why. But I do fundamentally believe that AI, LLMs, GPTs are in the business of predicting what should happen given what they have seen. And that's fundamentally a statistical process. And so if you have a knowledge of regressions of ordinary least squares or OLS, it's possible to build up from there to how an LLM works. And I think the thing that blows my mind about this is not the actual method itself. It's the fact that it works at all, given the complexity of language and the nuance of language. The fact that we were able to squeeze this into like a few billion parameters and do a pretty good mimic of human language is actually truly what blows my mind.
Yeah. So I love this distinction between the theoretical and the practical, and you know, and also in a way in the academic departments, the statistics department versus the CS department, and it it has often been said that people don't actually understand how these LLMs work. And I'm not sure that's entirely true, but I think it probably is true that they can't answer the question why it said the things it said, if that makes sense. That distinction makes, like, they know it works and they know at least at a high level how it works, but they can't answer the question how it specifically works. Is that a fair way to say it, or am I misstating the case?
It's the same. I think the analogy I'd use is like, we understand why neurons work, but we don't understand why the brain does what it does specifically in any specific instance. Like, you can kind of point at, like, even in like large language models, you could in theory look at all the weights and parameters and see what changes when you kind of pass something through it. But like, why those particular things actually have, like, what do they represent is a question that's not easily answerable. And it's a case that happens with like most complex systems. It's like you get what are considered emergent properties or behaviors that aren't easy to explain. And in fact, like, I kind of go link this to my like first ever job in macroeconomic research. In macroeconomics, when you're studying like large economies, you're studying emergent properties that come from like the firm, the individual, the consumer, all of whom you can easily model. But then going from there to like predicting like what happens at a macroeconomic level is kind of hard. It's not that if you build like the building blocks, you can kind of suddenly put a macro economy together. And that's also why like forecasting macroeconomic stuff is hard, because you don't know how these things interact ex ante, and you're sort of left with testing everything empirically, which is the place we're at with a lot of LLMs. It's a lot of like just empirical research on exactly what they do well and what they don't do well, and the why is a really hard question.
Yeah, and I think this idea of emergent properties is a really important one. One of the other things that I did as an undergrad is we had a class on programming, and for lack of a better idea of what to do, I decided to program Conway's Game of Life. And I think it's a great example of a set of very simple rules that then produce really unexpected outcomes. And my favorite example of this is somebody sort of proved that the Conway's Game of Life is a Turing complete program, that you can actually build essentially a microprocessor that can do anything using the bits and pieces. So this very simple, binary on-off thing from which emerges effectively an entire computer. A good example. So you've hosted a number of discussions on what it takes to go from cool science or academic research to actual products that people use in the real world. And I'm curious from your perspective, as you've seen a lot of different companies think about commercializing AI technology, what are some of the big mistakes you see people making in the AI space today? And there are plenty of examples of people doing cool stuff with AI or new stuff with AI. But what's the difference between something that's cool and something that's actually a useful product?
Yeah. I think, I'll focus on, I'd say, a learning rather than a mistake that we've had with ekai when we rolled out our first version of the product, is underestimating the UX side of the interaction between LLMs and human beings. And I see this in a lot of other products that incorporate LLM specifically. AI is broader than that, so I'm not going to touch on that, but LLM specifically into their workflows. And I think the challenge there is that LLMs do such a good job of mimicking human speech that you sort of expect to interact with it as you would with a human being. But there are certain very key differences, as that, humans can do that LLMs cannot do at all right now, or, they may get there. But at this point, given the technology we have today, they just don't do that. And so like one example is that if you assign any, like a classification task, kind of tell an analyst like, hey, there are these pieces of text, I need you to like label them with like 1, 2, like XYZ labels and so on. If a good analyst is ever confused about something, you can come back and say like, hey, I don't know about this, like, could you review that? And so they can point to where there are instances where someone needs to come step in. And so this is what we would call calibration, which is they have a good sense of like what they are unsure about. Unfortunately, LLMs, somewhat by design and somewhat by accident, just don't have a good sense of that. And so, but when you as a user are interacting with something that sounds human, you feel like it should be able to do that. So that's one thing. And then the other thing is, as human beings interacting with each other, we have a lot of context. It just, like I know what you do for a living, for instance, Anthony. So like if you talk to me about a certain subject, let's say you talk about sales, I sort of have knowledge about what you think about when you say sales, given what I know Tamer does. And so we, again, like an LLM doesn't necessarily have that. And so it's a different way of interacting with an LLM. And so we haven't quite figured out what that is. Final thing I'll add in terms of just those interactions is they don't know what they don't know. And therefore, they don't know what to ask you to get to the point of knowing everything they need to know for the thing that you want them to do. So that's, again, a very human thing. And so they have these like amazing, insanely good capabilities and sort of sound like a human being would sound, but then they have these like completely different ability, like lack of abilities, I would say, from a human being. And that, I think, will really trip up users because they are interacting with something that in their head, subconsciously, they think is a human-like experience.
So I think that's probably very true. This anthropomorphizing, it's a tough word to say, anthropomorphizing of the LLM. I mean, as humans, we're always trying to find shapes in the clouds. We're trying to understand patterns, but we also want things to have intent and emotion and specificity of, like goals and this sort of thing. The framework that I've written about and I've used is that LLMs are a lot like interns in that they work very, very hard. They don't know very much, and they're of reasonable intelligence, but not great intelligence. And then further, I've sometimes mused that the LLM is like an MBA intern, which is not only do they not know a lot and they're willing to work hard, but they are quite eloquent and they're very reticent to raise their hand and ask for help because, as like a typical MBA intern, they just want to sort of go and do the thing, and reality be damned, they'll just kind of like plow ahead without sort of pausing and to your point, asking a question. So with that as context, you've done a lot of work with LLMs, specifically around this idea of how can you write a data model with accuracy and completeness? Maybe it'd be wonderful if you could share from your experience and vantage point where you see the real world limits of LLMs in the enterprise data world. In some ways, like what are they? Where do you get surprised by how good they are, and where do you get surprised by just how awful they are?
Yeah. I think in general, like within the enterprise world, and this because you're in the startup business as well, Anthony, but having the right context is pretty critical in terms of having the LLM do the thing that you would like it to do. And each enterprise's context is unique. Each enterprise's like internal vocabulary is unique, like how someone defines customer acquisition cost. I mean, how someone defines a customer may be different within a single enterprise, right? And so LLMs have this like great understanding of just general knowledge, but in order for them to do the thing you want them to do within an enterprise, they have to like understand what is unique about the enterprise and knowledge that essentially sits within the enterprise. And that's often diffuse, often amongst people's heads, sometimes amongst like PDFs, sometimes amongst like Excel models version 24.0 something. And they need to somehow sift through it, access it, figure things out, like do stuff with them. I think the thing that like blows my mind sometimes is when we're doing data modeling, for instance, and we want to figure out if like two columns that are like badly labeled, but and like may not necessarily have metadata, like are like represent the same entity. They actually do pretty well. And I'm talking about like the reasoning models here. They do better than I would expect human beings to do. Now, having said that, like the baseline for a human being for that specific problem is still like a bad baseline. Like you wouldn't want to sell that as a product, but just like the ability that they have to infer stuff from like information that they have somewhere. I mean, I don't even know where in their weights or parameters they have that, but they somehow have that, is pretty good. But even pretty good sometimes is not like productizable, if that's a word. Like it's not the level you want to have it at to be able to sell it at. So they do a lot of things better than human beings do in terms of exactly what we do, which is like inferring data models, inferring like what's called the semantic layer. They do it perhaps better than an intern would, but it's still not at the precision where like if you were to present it back to management or some executive, they'd probably be like, what are you talking about? So you still have to build guardrails in. And unfortunately, since like the capabilities of LLMs are still fairly, or I think I believe these were researchers at HBS, I may be wrong about this, who coined the word jagged frontier, or at least this is what I've seen as. It's unclear where they'll trip up. So you need to do a lot of testing. You need to set up a lot of testing and guardrails in order for them to actually do the thing you want them to do reliably, since they are fundamentally like a stochastic process.
Yeah. So again, it feels like the intern analogy is spot on. Just as like, a way of summarizing what you just said is you wouldn't put the intern in charge of the board deck. You might ask the intern to build a slide or provide some data or, but you would not ask them to just be like, yeah, here, you do the board deck. And while you're at it, why don't you just present it? Like, you'd be like, no, that's a terrible idea.
Exactly.
And then we seem to turn over these tasks to LLMs as though they can do it. Also, this piece about context feels both very relevant and incredibly important. The large language models are obviously trained on internet content. They don't know anything about your business. And so techniques like RAG, where we can surface context into the model, aren't just sort of nice to have, but arguably are kind of critical, wouldn't you say?
Yes, although I will say something slightly different, that like RAGs for us are last resort, because surprisingly they have enough knowledge about, like, if I were to say that like Tamer does master data management, it knows enough about what that is and can figure out like if I'm looking at your data structures, like what things probably are, and then also figure out like from maybe column names, other metadata, etc., like what things should be. And as I said, with all of that, it actually gets to a pretty good level of understanding. I try to, like, as I said, like we use RAGs in our product. I personally try to stay away from RAGs because I think there's like basically cheaper and easier ways to do like, I would say, like multi-agentic methods to get to the same outcome that you would otherwise have with RAGs. Obviously, like there are certain instances where RAGs are unavoidable, like completely. But it's chunking things into tasks rather than like pieces of text that you kind of store in a library and then like retrieve them and then feed them back into an LLM. Yeah, maybe. But like, I think there are other ways to be like, let's say like something we were talking about earlier before we started, knowledge graphs. Building knowledge graphs, retrieving them, using them is actually like much more interesting and helpful.
Yeah. So to say it differently, giving them a tool that they can use to navigate a tree of knowledge is better than just handing them a piece of data. Is that a better way, or a reasonable way of saying it?
I think.
Or how would you say?
I try to not make generalizations with that. My standard answer with like anything with LLMs is like, it depends. Build a framework, test it, be empirical about it. Like, I think like the beauty about it, like modeling something as a statistical process, you can often like test it. And as long as you set your tests in advance and you know what you want and you know what good output is and bad output is, and you have the capacity to like label stuff, you can do a pretty standard process. Just experiment and figure out like what stuff it's good at, like what do you care about, and go from there. So like I also find leaderboards not very helpful. Like there are just like LLM leaderboards and all. Like it's sort of like it's almost a cross of the LLM and like the task you put it. That's what I care about, right? And all of these are empirical questions for me.
So I want to go back to something you sort of mentioned, but I wanted to maybe dig into a little bit more detail. This idea that humans and AI systems will work together. And this goes to something that I've sort of complained about in the past, which is my feeling is that the industry is over-indexed on this chat interface, that it's maybe the curse of ChatGPT, having released the interface to the LLM as a chat interface. And it's probably worth noting that OpenAI's first interface was an API and only almost like as a fun experiment, threw a chat interface on it to see what would happen. And now that's taken off. But anyway, now that we've anchored on this chat interface, it feels like everything has become a chat interface. Like whatever the problem is, we're going to put a chat interface on it. And that feels very limiting. So I guess first part of the question is, would you agree that it's limiting? And then what have you seen as more effective human AI interfaces?
So I agree that it's not just limiting. I think it's an awful experience for the user. Like, I just think it's an awful experience. I think it's like insane that in the last, like, I don't know, 10 years of UI innovation, this is the best we could land on. It's just kind of like, we had chatbots like 10 years ago, more than 10 years ago, maybe. But like this is the fact that this is the best we could have come up with is just like mind blowing. Like I'm dead sure that something exists that's a better interface than like, what we have today. So for sure, I don't know where we're still stuck here, but I think I also don't know I know what a different interface may look like, but I don't have a good intuition on like what a better interface may be. And so, but I'll make 2 points here. One is, I think human beings will also adapt to AI. So in the sense that like, when you speak with someone, when you work with someone, you sort of learn their habits, you learn what works well, you learn that through interaction. Like you learn how to say stuff. I mean, that's sort of like a manager role, like how to like, frame things, say stuff so that like you get what you need, or you get to motivate the person. And I think it's the same thing with LLMs. It's going to be a different way of communicating. And I think humans will figure that out. And I think people who are like interacting with it more often will figure it out faster. And I think that's probably where the innovation is going to come from, is that like someone who's younger than us, who spends perhaps more time actually interfacing with an LLM, will figure out like this is not actually the best way to kind of interface with them. I see a pretty big role for voice here as well. But yeah, I guess I don't know. I think like the second point I was going to get at is like, it's also unclear to me what the best interface for LLM to LLM conversation is. Because right now they're sort of like talking to each other in like human language, but like, is that the best way? Like, I mean, like they don't need to do that in any way. It could just be, I don't know, exchanging some version of like embeddings, some token sequences that they've come up with that don't make sense to us necessarily. So I think those are things that both the models will learn for themselves and also like people will learn. So I know I haven't answered your question on the UI piece, but like frankly, I just know that what we have right now suck, but I don't have a better one for you.
No, I think it is a hard problem. And I think it's, in a weird way, I suspect people have settled on the chat interface because they haven't invented better interfaces yet. That being said, I would say two things. One, there are lots of modes of interaction that we have with computers that LLMs would fit very nicely into. Not to sound very old school, but email. I mean, sending someone an email or an asynchronous conversation that occurs over time is not an unreasonable. It's the way many of us interact, and is not chat for sure. Yet we don't do that with LLMs. The other thing you said there that I think is really important is that we change our behavior to adapt to the technology. And this is, I think, something that people spent far too little time thinking about. And it's not just about computers, but there's so much about the way we interact with the world, which is as much about us modifying our behavior to adapt to the technology versus the other way around. Um, and you when you think this way, you realize all kinds of things we do that are not because it's optimal for us, but it's because it fits into the system that we've designed. So I also, maybe just to bring it back to data and data analysis for a second, you know, in the realm of data and the way people work with data, um, there's this role of the data analyst, and this is something you've written about and spoken about in the past. How do you think the role of the data analyst looks in 5 years? And how are they using AI, or are they completely obfuscated by AI? Like, is there even a role for an analyst anymore?
So I mean, this is going to be hard to predict. I feel like with AI, anyone who is somewhat data inclined can do data analysis themselves. So, like if you have some sense of how to slice and dice data, some sense of like, if you are in some function that requires A/B testing, that like how that works, if you're some function that requires like ML stuff, like I think you're going to have enough, like AI, like do enough stuff for you that for basic data analysis, descriptive statistics, etc. Like anyone who knows what they want can get it done. I think the role of a data analyst, so to say, is probably going to shift more from that to kind of creating a like more of an like I don't know, knowledge analyst, for lack of a better word, like creating the infrastructure that is needed for anyone who wants to do data analysis to do accurate data analysis. And so they'll perhaps be in charge of like almost like librarians of a company. They kind of are in charge of like understanding what knowledge sits where within a company and who should have access to what and so on. So I think that will be a more specialized function within a company. The other thing I'll add is that I think the role of an engineer is probably like a data engineer is, I think, going to be merged with like a classical software engineer. I don't think you'll necessarily have a big kind of difference between the two, because fundamentally, like if you do any kind of like data analysis or do any type of data prototyping on building, let's say, a data mart or something, I think that prototyping part, it's already much easier now than it used to be. But now you'll have instances where someone who's not quote unquote technical will be able to build those pretty quickly. And if it's helpful for them, they will probably take it to someone who's in engineering. And then their job is basically the scale up part, which is much more software engineering aligned than like classical data engineering, so to say. I also think that like a lot of the data engineering frameworks that we have in terms of how the data stack is structured will have to like shift radically. I think there's going to be a lot of like automatic decentralization of data use. And so, I don't think you can have a central org, like a data team that does a big data team, at least, that kind of like centralizes everything and then makes it available. I think, if I am a product manager for an app, currently my data kind of, the transaction level data gets kind of sent and processed and like sits in some or like analytics, like OLAP place. And then I can access some layer that someone has given access me to. Those are like 10,000 different steps. But like the data like actually sits with me. Like it's right there. Like I get the transaction level data in my app. So like I should be able to just query that myself. It shouldn't have to go through all of these loops and then come back to me. So that's what I mean by like, but then if I want to build something, like I want to build like a pricing model or something, I still need like something. If I want to put something in production, I still need to kind of take it to an engineering team. So
Yeah. So let me test this against you. So I admit, at the risk of dating myself, if you go back into the 90s and you wanted to build a system for managing your interactions with customers, you could get an Oracle database and a 4GL programming language, and you could build a CRM system. And along came Tom Siebel, and he said, well, this is stupid. Like, we know how to do this, and we're just going to build the system, and you can just buy it from us, and it's ready and it works. Maybe you customize it, but largely it works. And I thought of that as kind of the app, and whether it's CRM or SAP with ERP systems and PeopleSoft, and like built an entire industry that are essentially appifying or building apps around these common business processes and business use cases. Another way to think about what you said is that the engineering talent associated with doing data engineering may not actually sit inside the organization that's using the data, but actually as a software provider that's providing an app that just does the thing. Like the number of custom built pipelines inside, like little companies around the world doing exactly the same thing as the 7,000 other, exact replicas of that pipeline in little companies. Like that feels like 4GL programming languages building a CRM systems in the 90s. But you're welcome to disagree.
Yeah, I don't think I disagree much. I think like the AI has created like two things that are like one thing that is similar to that and one thing that I think is different. One thing that I think similar is like anything that can, any kind of like, fundamentally anything that can get automated does get automated in software engineering. So like anything that like, this is not just data engineering, but like if you have enough people building the same kind of pipelines over and over again, someone's going to build a product for that. I think that's kind of this part that I think is similar to what I do. The thing that I think is different about AI is that I think that once it actually has, like once an enterprise does have an AI system or like some kind of that understands its data, understands its contract, understands its knowledge, there's stuff that it can do that even like the actual employees may not have thought about. So there's stuff because it'll understand, let's say your business context. It can probably suggest, let's say, features for like, if I want to build like a pricing recommendation system, it can probably suggest what those features would be. And I don't need to be like a machine learning expert for that, right? And so like, obviously like there are people who say like, oh, there's like risk associated with like, someone who's not an expert in machine learning to like just run a pricing system and all. But, I sort of compare this to like the flip side where I've seen people who have, like just a very rudimentary understanding of statistics, like run regression models and base very large decisions at both enterprises and the public sector just based on like correlation coefficient. Yeah. So like, that'll happen. That's what happens when something gets more widely available. But it doesn't mean like, I don't think it's necessarily a bad thing because otherwise they would have done it on just like, you can't see what I'm doing right now, but just kind of like plucking something out of like the air. So,
right. Yeah, no, that's a great point. And I think that analogy is actually a good one. As we sort of wrap here, I want to maybe step way back. And you've had quite a varied experience, thinking about startups and large companies, established Western markets, emerging markets. So from your perspective, do you think the innovation in AI, which is clearly very disruptive, is going to, do you think this ends up being dominated by, a few big, large incumbents? Or this is a case where we see a set of new players emerge, that are small startups today, but become the new disruptors. And similarly, and maybe very differently, is this yet another technology that the Western world sort of dominates and becomes the leader in, or is there an opportunity for emerging markets to leapfrog here? Those are big questions, but I've just given your background, it seems like I have to ask.
Those are like great questions for the end. The first question, Look, I want to believe that this time won't be different, and we will have like new companies kind of emerging and taking on the bigger ones, and like disrupting like the industry as it stands today. And I think like that's a healthy thing. It's a good thing. It emerges like new cultures, new corporate cultures, new ways of doing things to emerge and so on, right? I think the thing that concerns me this time around is that like the power of LLMs is like directly correlated with how much knowledge and information you have, which a lot of like larger companies have spent, I don't know, couple of decades at least, just gathering and hoovering up and putting on there. So like, do I think this time, like, I don't think, so I don't think like large companies fail because they don't have like a competitive, like an economic competitive advantage. I think they fail because they kind of just are too far removed from the actual user, or the actual like, they're too far removed from the actual like market trends to like notice what's going on, and then by the time they get around to it, they're kind of lost. But this time may actually be different. I don't know. It's like if there were to be a time where something is different, well, it may be the AI, just because of the nature of the technology, the AI revolution. I think the emerging versus Western markets thing, it's a hard question. The way I like, the thing I kind of like talk about, which is like a subset of that question, um, which is labor markets, which I kind of like think about, because I think over the last 50 years, like we as the world have liberalized what I would consider like the market for goods and the market for money, which is like, you have pretty easy transfer of money, pretty easy transfer of um goods across the world, for now at least. And then, but we never really got there with people, like with skills, basically, less than people with skills. So those things like sort of stayed frozen. And so you have seen rather over the last 50 years, I would say, that those differences diverge, like the wage gap, the salary gap for like the same skills in different markets, like is quite high. I think AI could be a great, and generally speaking, software is a great equalizer for that to an extent. I mean, there are other things that like, you can't, let's say like, if you're hiring someone in like a third world, they sometimes have to be concerned about like, do I get electricity or not at certain hours? I grew up in one such country where I also often have to like think about, am I actually going to have electricity like between this and these couple of hours or so to get my work done, right? So like productivity still gets impacted because of the environment you're in, but like the fact that you can still do stuff as a skilled person without having to move from point A to point B will mean that a lot of this wealth transfer that otherwise was not possible will still happen. So that's kind of what I'm optimistic about. And I think that the thing that like is amazing for me, just like blows my mind, is like the amount of knowledge that you now can package into a little model that is available to anyone. And so anyone can look up how to do certain things, how to like edit their emails, how to like communicate properly. I think we underestimate how much of an impact that can have in terms of like economic growth, especially for like skilled labor. I think I have more concerns around how AI can be used for consolidation of like state power in certain places, and especially then in emerging markets or in the third world. Like, I think that's actually where I think like most of my concerns are. I think as like a pure economic force, I do believe it will be a net positive. Even if like the majority of it, like the bulk of innovation is going to happen, of technological innovation will happen here, there will be applications in terms of like business model innovation, in terms of operational innovation that will still come out in these countries. And I think it'll come out faster than we've seen before. They'll kind of figure out ways to use AI in ways that we can't anticipate within those markets. And I am pretty excited about that. I am not excited about the potential for abuse, basically.
Yes. But again, hopefully, like any technology, which of course there's always room for abuse, the positive uses and leveling of the playing field dominate as the effects. I mean, there's always some bad actors.
Yeah. I think there are always some bad actors, but I think, I'm hopeful that we, find a way to like, people find a way as like civil society kind of figure out amongst themselves like how we manage that. So
Cool. Well, I think that's a great place to end. I appreciate you making the time and joining us on the show.
Thank you, Anthony. Thank you for having me.
Thanks for joining us for the latest episode of the Data Masters podcast. You'll find links in the show notes to any resources mentioned on today's show. And if you're enjoying our podcast, please subscribe so you never miss an episode.